So for 11.4, we're going to take a look at quadratic applications. We actually have seen a few of these back in other chapters. I think chapter 5, when we learned how to factor polynomials, and we saw some of them come up quite a few times while we're solving other types of situations, like rate of work, some of our applications in chapter 10. So we're just going to take another look at it. That's why I kind of call this round 2. It actually might be round 3. Just another round of quadratic applications now that we know how to solve quadratics and work with them. And essentially, the first thing that's kind of new is this idea of solving a formula. And the trick to it is one of our variables is either squared, right, or the variable we're trying to solve for is underneath the radical. So essentially, we're going to be playing with the square root property, right? The good old a squared equals a number. We square both sides, introduce our plus and minus, and we get a equals plus or minus whatever that number is. And of course, to undo a square, we just square root, to undo the square root, we just square both sides to get rid of the radical. All right, and then there's some more complications coming soon, but sometimes it's that easy. All right. Second of all, what we're going to be doing, not only going to be using this old skill, but we're just going to continue to use the golden rule. It's a little bit scary to be pushing around variables. We're used to pushing around numbers. You add a number, subtract a number, divide a number. We're used to doing that, but we're going to continue to play the same golden rule as we try to isolate the variable that's being solved for. So without any further ado, let's see how this is going to work. So in the first one, we have a equals 6s squared, and we want to solve for s. All right, so what we're going to be doing here, right, is we got to get this s by itself. So I think the best way to start this is to divide both sides by 6. And so what that gets us, right, let me kind of rewrite this, is we get s squared equals whatever a is divided by 6. And so here you can kind of see we're pushing around a variable. We're used to doing that division and actually getting another number. But right now we don't know what a is, so we're just going to leave it alone. And to get this s by itself, I would basically take the square root of it. Whatever we do to one side, we do to the other, right? And we're going to add a plus or minus because of our square root property that we learned way back in chapter 10. So this gets s by itself, and then we got a little bit of a train wreck over on the other side. And so a lot of that kind of depends on how the textbook would like its final answer. I know we already know that that's kind of a crazy aspect, but I know I can initially break this up, and then I can rationalize the denominator, which usually needs to happen. So one potential answer, right, is plus or minus. We're going to get the square root of 6a on top. The square root of 6 times the square root of 6, right, would just be 6. So I would imagine that that's the way the textbook is going to want the final answer, because not only have we solved for s, but we've also simplified the radical as much as I can. So I'm pretty sure that if you're lucky, maybe it accepts that unsimplified version up there. So try that first and then see how that goes. If it doesn't work, simplify it and just follow directions. Otherwise, ask questions in class and we'll figure it out together, because we do know Pearson can be a little tricky. B, we got another formula, right? And we're supposed to be solving for the variable L. So somehow we got to get this L by itself. For starters, I noticed that it's underneath a radical, so we're going to have to undo that radical. But like we saw in chapter 10, the way we do that is we start isolating it. So I think the best thing to do here is to divide by 2. Let me rewrite this as the square root of 5L equals R over 2. And then, of course, we're going to square both sides, because that's what's going to get rid of that radical. And, right, with the radical being gone, we're left with 5L. And over here, we get R squared equals 4. And we're going to divide both sides by 5. And so L right now is R squared over 4 divided by 5. Got to clean this up. I know for a fact Pearson's not going to accept this as an answer. So if we think of 5 as 5 over 1, you can see that we're basically dividing fractions. So L is R squared over 4 times the reciprocal, and so I'm getting R squared over 20. So L equals R squared over 20. I'm going to put that in my Pearson homework and be off to the races. All right, so There we are solving some variables, solving some formulas. You can see that I'm essentially using the same golden rule. Add, subtract, multiply, divide. The same thing, whatever you do to one side, you do to the other. And then I'm making use of the square root property, or clearing radicals, that we've seen before. Let me do one more on this video because things do get a little tougher. But in this video, we're supposed to be solving for b, so we got my nice Pythagorean theorem, and I want to get this b by itself. All right, so I'll begin this journey by subtracting a squared from both sides. So I end up with b squared equals c squared minus a squared. So to get this b by itself, I have to undo that square. So I'm going to take a square root. Whatever I do to one side, I introduce to the other. All right, and so we end up with b, and then plus or minus c squared minus a squared. Right, and this will not simplify anymore, right? Because we have a plus minus. We have a minus statement in here, and we've seen that this does not equal c minus a. You can't apply that radical over pieces, right? We saw that back in chapter 10. That's a classic mistake that I hope I talked you guys out of. So that is the final answer. One more thing before I go. With regard to the plus or minus answer, again, the formulas we're using here are actually mathematically modeling real-life situations. For example, this one, we know that this is mathematically modeling the relationship between the sides of a right triangle. And up here, this is going to be harder for me to draw, but we're dealing with a cube that's S by S by S, all right, and we're talking about the surface area. There's 1, 2, 3, 4, 5, and 6 surfaces, all with S squared. So this also has some real life meaning. So because of that, we're usually going to be using the plus answer, and that might also impact, I'm kind of thinking Pearson's so picky, they might just want the plus answer because we are mathematically modeling some real life situations, and it doesn't make sense to have a negative length in either one of these situations here. On this side, since we're getting rid of the square root, it doesn't really matter. There's not a plus or minus. Things took care of themselves. So keep that in mind. Again, if you run into some issues in the homework, just ask questions in class and we'll figure it out together. Alrighty? So there's basically your introduction to formulas. A couple tough ones are coming soon, but I'm going to save those for the next video. See you guys soon.